NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams.
Prepare for astonishment as the James Webb Telescope uncovers a stunning revelation in the world of astronomy. Pluto's surface reveals enigmatic movements that have scientists enthralled, eager to unlock this cosmic puzzle. What did the telescope see during its most recent mission? The mysterious activity recorded on Pluto's surface has scientists and astronomers captivated, fueling an insatiable urge to solve this cosmic mystery.
The largest telescope ever flown launched into deep space, its primary mission is to reveal the "let there be light" moment, when the stars and galaxies first ignited after the Big Bang.
Are we on the verge of discovering the universe's biggest mystery? Stay tuned to find out. What was discovered on Pluto? Signs found by the James Webb Telescope indicate an unreported catastrophic incident occurring on Pluto, according to sources. According to the data, this incident has significant implications for our understanding of the dwarf planet's geological history. The telescope detected an unusual quantity of heat emanating from the planet's surface. By utilizing its powerful infrared capability, precise temperature measurement and analysis were achieved. Based on further data analysis, a colossal entity brought about the collision, potentially either a comet or asteroid. A powerful collision occurred with Pluto. The impact would have caused a tremendous shockwave, causing extensive devastation across all areas of the planet. Stick around as we dig deeper into this discovery on Pluto. An understanding of the James Webb Space Telescope. The Hubble Space Telescope has been surpassed by the James Webb Orbit Telescope, which is now considered the most advanced telescope in the orbit. It is created to transform our comprehension of the universe. From the very beginning, the Webb Telescope was intended to surpass the Hubble Space Telescope in performance, and also surpassing it in a number of ways. One of its primary objectives and main focus is on examining faraway celestial bodies. There has been unmatched anticipation and curiosity generated among scientists and the general public due to its recent observation of Pluto. The development and premiere of JWST showcased the resourcefulness and persistence exhibited by the scientists. When it was initially released in the mid-1990s, the optic tool experienced a range of technical hurdles coupled with budgetary restrictions. International collaboration was needed for completing the project. On December 25, 2021, an Ariane V rocket played a vital role in launching the JWST into its designated orbit and later into orbit via the European Spaceport in French Guiana. NASA, the European Space Agency, and the Canadian Space Agency collaborated with the goal of developing and launching the James Webb Space Telescope. During the 1990s, there were some issues and scientists had to overcome major financial and technological difficulties, leading to delays and debates regarding its practicality. A brief introduction of the planet Pluto. The general consensus for quite some time was that Pluto occupied the position of the 9th planet in our solar system. Later, however, it was reduced to a dwarf planet by the International Astronomical Union in 2006. Because of its small size, this decision was made. Situated within the Kuiper Belt area and teeming with frozen celestial bodies located after Neptune, approximately its average distance from the Sun is 5.9 billion kilometers to 3.67 billion miles thereabouts. In spite of its proximity, according to astronomical measurements, the extensive distance hinders observation. When NASA initiated the New Horizons mission in 2006, the curiosity to explore Pluto further heightened. In July 2015, New Horizons completed its strenuous space voyage and reached Pluto after enduring a demanding expedition through the cosmos. This groundbreaking mission was responsible for providing Earth with its initial close-up pictures of this remote planet. The telescope's powerful capabilities. The JWST, alternatively referred to as the James Webb Space Telescope, was designed to decipher the enigmatic mysteries of the universe, which, as we all know, is a technological feat. Its unique capabilities and instrumentation distinguish it from past space observatories, providing new potential to investigate the universe in ways which were never possible before. JWST places significant emphasis on studying the infrared spectrum, making it one of its standout aspects. Not similar to visible light observatories like the Hubble Space Telescope, the sensors on JWST are engineered for detecting infrared radiation originating from celestial objects because infrared light has longer wavelengths than visible light. By penetrating through opaque dust clouds, JWST can unveil unseen cosmic processes affecting visible light objects. The central element in the architecture of the JWST is a remarkably large primary mirror spanning 6.5 meters or 21.3 feet. This mirror is more than 7 times bigger in comparison with the primary mirror of the Hubble Space Telescope. It allows the JWS to capture substantially more light and attain superior resolution in its studies. Due to the upgraded light-gathering capacity it possesses, dim and distant celestial objects are now accessible for investigation by the JWST objects that conventional telescopes couldn't detect or observe. JWST's most captivating missions include deep-field observations. JWST will focus on tiny areas of the sky for lengthy periods of time during these observations. Such functionality permits it to perceive exceedingly far and distant entities. Observing previous eras has been made possible thanks to this, along with observing galaxies that originated just after the Big Bang. Due to this, a deeper knowledge of the early cosmos's past will be attained. Moreover, the James Webb Space Telescope is forecasted to have a substantial impact for researching exoplanets. Planets known as exoplanets are located beyond our solar system. By scanning, its sensors will try to detect evidence of environments suitable for life and potential signs of living organisms in the atmospheric compositions of these distant worlds. The delivery of essential data in the exploration for alien existence will be carried out by them. Let us see what this creation can discover in the cosmos and mesmerize us with now. A raging dust storm detected outside our planet. For the inaugural occasion, researchers utilized the James Webb Space Telescope, JWST, to observe a turbulent dust storm occurring on an exoplanet situated beyond our solar system. The exoplanet under investigation is VHS 1256b. It is around 40 light-years distant from Earth. Not like the conventional sandstorms seen in arid desert areas, this tempest resembles more of a fog made of rocks, with dust particles made up of silicates. Small grains comprising silicon and oxygen. These silicates form the foundation of most rocky minerals, commonly known as VHS 1256b, sometimes called a super Jupiter. It resembles our solar system's gas giant, but is far bigger. An estimation suggests that its mass is by a factor of 12 to 18 compared to Jupiter. It circles a pair of stars at a significant distance, almost 4 times that of Pluto from the Sun. The temperatures between VHS 1256b and a burning candle's flames are indistinguishable. According to Professor Beth Biller's statement from the University of Edinburgh and the Royal Observatory Edinburgh, this makes it a hot and youthful celestial object. The dust particles during this storm are remarkably small, similar to smoke particles, composed of granules made from silicate materials. These observations indicate that there might be multiple layers of silicate grains in its atmosphere, with the smaller grains higher up and potentially larger ones deeper down. Discovery with James Webb Space Telescope. The improved capabilities of the James Webb Space Telescope enabled the unprecedented discovery of the dust storm on VHS 1256b. The telescope analyzed the light radiated by the exoplanet and carefully disentangled its component colors to determine the makeup of its atmosphere using its mid-infrared instrument, MIRI, and near-infrared spectrometer, NIRSPEC. While the primary mission of James Webb Space Telescope is to study the pioneer stars and galaxies that emerged shortly after the Big Bang, its advanced tools, namely MIRI and NIRSPEC, have provided a unique opportunity to explore exoplanets like never before. By studying the atmospheres of these distant worlds, scientists hope to gain insights into their composition, climate, and potential habitability. The revelations from the James Webb Space Telescope not only offer a captivating glimpse into the mysteries of a distant exoplanet, but also hold the promise of investigating whether some exoplanets could harbor conditions important to hosting life. The presence of carbon monoxide, CO, and methane in VHS 1256b's atmosphere suggests a hot and turbulent environment with materials being drawn up from its depths, creating an intriguing avenue for further research. Revealing the enigmatic WR-124. The data gathered from James Webb Space Telescope's near-infrared camera, NIRCam, and mid-infrared instrument, MIRI, have provided a remarkable view of the clumpy structure of the dust surrounding WR-124. This newfound clarity has enabled astronomers to delve into the mechanisms of dust production, analyze the size and quantity of dust particles present, and investigate how dust from similar Wolf-Rayet stars contributes to the overall dust content in the Milky Way. Understanding these processes is essential, as this dust is later recycled in the formation of new stars and planets. James Webb Space Telescope telescope's infrared vision has proven invaluable in peering through the dense clouds of dusty gas that obscure star-forming regions, offering insights into star-birth processes that were previously hidden from our view. This enhanced sensitivity and detail have not only provided a deeper understanding of star formation within our galaxy, but also extended our reach to explore star formation in other galaxies across the universe. The data gathered by James Webb Space Telescope is unveiling the enigmatic origins of our own sun and the formation of the solar system, providing a glimpse into the birth of celestial bodies. Surprising discoveries and the hunt for sulfur dioxide. Hot Jupiter, which are gas giants situated very close to their host stars, have been the easiest exoplanets to study due to their strong signal emissions. The telescope's earliest exoplanet results have been drawn from these intriguing giants, such as WASP-39b, located 700 light-years away. It employs transit spectroscopy, which involves analyzing starlight as the planet transits across the face of its star. This process allows astronomers to detect specific molecules in the exoplanet's atmosphere by observing their unique absorption lines in the spectrum. The precision and quality of the telescope's data have surpassed expectations. Sulfur dioxide molecules in the atmosphere of WASP-39b were discovered by researchers. Sunlight-induced photochemical reactions involving atoms and molecules present in the atmosphere gave rise to these molecules. Sulfur dioxide being detected by the telescope was unexpected. It validates the telescope's capacity to uncover unforeseen chemical processes in exoplanet atmospheres, adding more certainty. During a period without telescopes, research of exoplanetary atmospheres was limited to hot Jupiter. The telescope's capabilities have expanded to include the detection of smaller, Earth-like planets. It is presently investigating the TRAPPIST-1 system's stony planets, despite the fact that its faint red dwarf star and small size make unraveling atmospheric characteristics challenging. A brief understanding on exoplanets. Extrasolar planets, often known as exoplanets, circle stars other than the Sun. Exoplanets have long been suspected of existence. Nevertheless, it was not until the 1990s that astronomers could confirm their presence by employing modern observational techniques. Ever since that time, researching exoplanets is currently recognized as a fascinating and swiftly progressing matter in the domain of astronomy. While the telescope keeps on investigating and characterizing exoplanets, we anticipate that novel and captivating discoveries will enhance our comprehension of the origins and development of these cosmic objects. The study of gas mixtures in planetary atmospheres enables astronomers to acquire extensive information regarding planet formation and the distances between planets and their host stars. This is done by investigating the mixture of gases present in these atmospheric conditions. Did you know that exploring the atmospheric compositions of exoplanets can uncover evidence pointing to the existence of life elsewhere? Yes, it's a possibility, and that is why scientists are doing their best to uncover these hidden truths. New findings from July 2015 mission. Although Pluto was visited by NASA's New Horizons probe around 8 years back, nevertheless, the monumental encounter is producing ongoing scientific results. It was on July 14th, similar to the year 2015 when New Horizons bestowed upon humanity their first close-up sights of Pluto. Just above the dwarf planet's icy expanse, the probe flew a mere 7,800 miles or 12,500 kilometers. The mission team is still analyzing the stockpile of data New Horizons gathered during the flyby. Moreover, recent results demonstrate that fascinating findings continue to be uncovered. On Tuesday, March 14th, the latest findings were presented by New Horizons researchers. The sharing took place at the Lunar and Planetary Science Conference, LPSC, being held both in Texas and virtually. Among the new findings, one tied Pluto's puzzling flip to its ice-filled basin. On the surface of the dwarf planet, another team discovered intriguing yet perplexing landscapes, while a different group revealed the components responsible for shaping the snowman-shaped entity, Arakoth, that was encountered by New Horizons on January 1, 2019. Pluto and Sputnik Planitia. In the past, Pluto flipped over on its side just like Earth. There is a lack of clear understanding regarding Pluto's orientation before flipping and the extent to which it adjusted itself. Researchers are using information from New Horizons in order to analyze the geological history of Pluto and to reveal indications that clarify this event. Presently, a collection of researchers has associated Pluto's reversal to the creation of Sputnik Planitia. The basin known as Sputnik Planitia spans 620 miles wide or 1,000 kilometers. This portion comprises 50% of the famous heart-shaped area on Pluto. Sputnik's significant role in reshaping the surface of the dwarf planet was already known by researchers, and it contains nitrogen ice. By employing the photographs transmitted by New Horizons during its 2015 flyby, efforts are currently being made to follow and analyze Pluto's flipping trajectory. While undertaking these tasks, parallel mountain ranges and deep valleys were discovered, which they speculate constitutes a worldwide tectonic system, extending a similar distance from Pluto's North Pole. These traits measure over 186 miles or 300 kilometers in width. Nevertheless, the evidence of Pluto's past orientation change indicates that none of the landscapes currently observed by scientists are situated where they originated, explaining that in the current setup of Pluto poses a real challenge. At LPSC, Oliver White of the SETI Institute in California shared his insights during a talk. According to him, these features likely existed along Pluto's equator early on and migrated to their current locations nearer to the poles because of the flip. White's team also discovered that Pluto's subsurface water gave some propulsion to Sputnik. This contributed in shifting the majority of the dwarf planet's mass towards its equator. Methane deposits spotted near Pluto. Apart from assisting scientists in examining the historic terrains on Pluto, there are indications about its more recent features provided by New Horizons data. The spacecraft had previously detected huge methane deposits near Pluto's equator, many as tall as Earth's skyscrapers. A recent declaration by scientists indicates that they now possess fresh evidence highlighting that these dagger-like formations may also continue onto the far side of Pluto after what New Horizons captured during its 2015 flyby. As stated by Ishan Mishra, a postdoctoral researcher at NASA's Jet Propulsion Laboratory in California, by uncovering these attributes, we are furthering our grasp on how functionalities contribute to shaping dwarf planets like Pluto, as well as other frozen worlds in our solar system. He further continued that it displays the intricate nature with constant alterations seen on planetary exteriors akin to those witnessed on Pluto. He also stated that identifying these characteristics will allow us to gain a better understanding of the forces that shape heavenly bodies such as Pluto and other icy planets in our cosmic neighborhood by presenting the intricate composition of planetary surfaces and the diversity of traits they share. On Earth, these structures are known as penitentes. They're composed of frozen water and extend only a few meters. On Pluto, however, these features primarily exist at the highest points on its surface and soar for hundreds of meters. At such heights, methane freezes out of Pluto's wispy atmosphere in cold weather and evaporates back into its gaseous state during warmer spells. Utilizing photographs captured by the Long-Range Reconnaissance Imager, LORRI, on board New Horizons, the team involved in the latest research conducted their study. How the light reflected from surfaces changes with different viewing angles was studied by them. As a result, similar methane absorption structures on Pluto's far side were discovered. Mishra stated during his presentation that the surfaces of Pluto were rougher than normal roughness. Such bladed terrains are expected to be among Pluto's most prevalent features, he noted. Coming across Arrokoth. On January 1, 2019, New Horizons passed Arrokoth, a tiny object in the Kuiper Belt that resembled a somewhat flattened snowman. It became the farthest object ever investigated by a spacecraft after being discovered 4 billion miles or 6.6 billion kilometers from Earth. It is also the most basic because of its remoteness from the Sun, which maintains it in a deep freeze. Arrokoth is the result of a gradual merger of two objects that originally orbited each other. According to experts, the bigger of the two lobes, known as Wenu, is a pile of 12 boulders gathered around a larger slab. The most recent discoveries indicate that Wenu developed not as a whole, but rather from chunks of rock that already existed in the solar system's outskirts. This is surprising, and it adds a new piece to the puzzle of how planetesimals, building blocks of planets, like Arrokoth and other Kuiper Belt objects come together, said Alan Stern of the Southwest Research Institute in Colorado. The Kuiper Belt, a huge donut-shaped sector at the solar system's edge, was produced early in its existence by millions of kilometer-sized frozen particles. Stern argues that a handful of them united to become Wenu, but that they did not merge at fast rates, explaining why Wenu is so lengthy. Stern's team believes that if the rocks had kept their shape after mixing, they would have moved at less than 1 meter per second. Stern's team thinks that the rocks would have been traveling less than 1 meter per second when they merged, since they preserved their form even after combining. A previous study indicated that Wenu interacted tidally with the smaller of the two objects. Both lost angular momentum by ejecting material and finally merged to create today's Arrokoth. The individual rocks resemble Lego pieces with identical sizes and compositions and colors, all of which tell us Something very important about the formation of Arakoth, Stearns stated during his conference presentation. Stearns' team discovered that each of Arakoth's 12 rocks is more than 3 miles or 5 kilometers broad. Given that Bennu is just 6 miles or 10 kilometers thick, astronomers believe the 12 rocks concentrated around its equator make up the majority of its body and extend to its far side, which New Horizons could not witness. Findings by scientist James Keene. The findings were reported on the November 17th by James Keene, a doctoral student at the University of Arizona's Lunar and Planetary Laboratory, who reached these conclusions through his research. His advisor, Assistant Professor Isamu Matsuyama, additionally contributed to the study. They provided evidence of frozen nitrogen pileup, which would put the entire world off balance, similar to a spinning toy, but with a clump of chewing gum connected through the process known as real polar wandering. There are 2 ways to change a planet's rotation, as stated by Keene, that one well-known change occurs when a planet's obliquity shifts, causing the spin axis to reorient itself in relation to the rest of the solar system. He went on to argue that real polar wander, in which a planet spins while maintaining its steady spin axis placement relative to other celestial bodies in our solar system, is an alternate way. Planetary rotation tends to favor in a way that minimizes energy expenditure. In essence, this means that planets prefer readjusting their orientation in order to put any extra mass closer to the equatorial area. Any mass deficits are placed closer to the pole. Let us put it this way: if there was a colossal volcano forming in Los Angeles, the planet would readjust its position so that LA is located on the equator. To understand polar wander on Pluto, one needs to understand that contrary to Earth, that has a slight incline in its rotation, resulting in the equatorial areas receiving maximum sunlight. Picture Pluto resembling a tilting, spinning toy. Therefore, the planet's poles get the most sunlight. One option is chosen over another, depending on the season. The equatorial regions of Pluto remain extremely cold all the time. As a result of Pluto being roughly 40 times more remote from the Sun than our location, completing one revolution around its axis takes about 248 Earth years for this tiny formation of rock and ice. In regions close to Pluto's equatorial lower latitudes, the temperature drops to nearly negative 400 degrees Fahrenheit, and sufficiently low temperatures can solidify nitrogen. Delving deeper into their findings. Over the span of one complete revolution around the Sun for Pluto, nitrogen and other exotic gases condense on the permanently shadowed regions. While Pluto spins around the Sun, the frozen compounds heat up, revert to gas, and condense, resulting in seasonal snowfall on Sputnik Planitia. With each revolution Pluto takes around the Sun, the heart stores a small amount of nitrogen, stated Keene. Once a sufficient amount of ice accumulates, potentially reaching a thickness of around 100 meters, it begins to overwhelm the planetary structure that determines its orientation. He further said that if there is an excess of mass in one place on Earth, it will gravitate towards the equator. Many millennia have elapsed since this phenomena originally produced sluggish displacement over its whole. In some ways, Pluto exhibits characteristics of being a dwarf planet, and the weather on Pluto directly impacts the way it takes form and its location in space. In my opinion, not many individuals had previously considered this notion of an entire planet being pulled along by the movement of volatile substances, Keene said. During the flyby of New Horizons, the 2 researchers employed the gathered observations and merged them with simulations generated by computers. By employing this technique, they were capable of modifying a particular feature such as Sputnik Planitia on the surface of the planet, relocate it across various regions of planetary geography, and assess its consequences on changes in spin axis. As anticipated, in the simulations, the geographical whereabouts of Sputnik Planitia turned out remarkably proximate to its projected location. If Sputnik Planitia were a large positive mass anomaly, perhaps due to loading of nitrogen ice, it would naturally shift towards the tidal axis shared between Pluto and its largest moon Charon as it moves closer to achieving its lowest energy state. Keene and Matsuyama state that this is so. To rephrase, the extensive accumulation of ice would eventually settle in a place that creates minimal imbalance in Pluto's spin axis. Findings suggest an ocean in the past. The Earth's moon and Mars have also revealed this phenomenon of polar wander. However, in those cases it happened in the distant past, billions of years ago. Keene claimed that the same processes are now taking place on Pluto. Keene went on to say that the link between its entire geology, which includes glaciers, mountains, and valleys, and volatile processes, is obvious. Unlike the bulk of planets and moons in our solar system, it has distinct characteristics. Furthermore, As suggested by various simulations and calculations, it was anticipated that when frozen volatile substances accumulate within Pluto's central region, this process will cause cracks and fractures to manifest on its surface precisely at those areas documented by New Horizons. Keene noted that Pluto's geological flaws indicate the presence of an undersea ocean at some point in its history. His analogy was that it's comparable to freezing ice cubes. He further added that the process of turning water into ice necessitates expansion. On a planetary scale, this process causes surface disturbances that look like modern-day faults. A report by Francis Nimmo of the University of California, Santa Cruz and colleagues is published together with the paper. They also evaluate the implications of Pluto's seeming realignment, in agreement with the authors of that paper, backing up the hypothesis that tidal forces can clarify the existing placement of Sputnik Planitia. Nonetheless, for their model to be effective, there needs to be a subsurface ocean on Pluto today. Both papers emphasize the concept concerning the surprising level of activity observed on Pluto. Keene said that prior to New Horizons, individuals generally associated volatiles with just a sparse frost coat, an external impact that could potentially alter the hue or have an impact on nearby geological features. According to him, the mission's findings imply that volatiles have a far larger role in shaping Pluto's landscape. No one would have predicted that the movement of volatiles and shifting ice around a planet could have such a dramatic planet-moving effect. The recent revelation from the James Webb Space Telescope regarding a mysterious object moving on Pluto has spread excitement and apprehension globally as a consequence of this incident. In its role as the top-notch space observatory engineered by humans, yet again showcasing its potential for advancing scientific breakthroughs, the journey of discovering the mysterious enigmas of our universe persists. Undoubtedly, the public will be strongly fascinated by the evolving storyline of this exceptional finding. It will stimulate debates about the incredible marvels found in space and the impressive accomplishments resulting from human creativity. As a representation of our shared aspiration to investigate the universe and unravel its numerous enigmas, we keep moving forward. It encourages a mindset of exploration and creativity that transcends national divisions, uniting mankind in the journey for wisdom. While uncertainties may persist, it remains vital to recall that these revolutionary findings are what drive scientific advancement. In addition, they motivate upcoming astronomers, physicists, and explorers. That's all we have for today. As we venture further into the unknown, we eagerly await the next scientific discovery that will captivate our collective imagination. Thanks for watching and subscribe to receive an update on our next video.